Section 3.1, tangent lines. Now we've learned tangent lines before in geometry. A tangent line is simply, for example, if you have a circle, then a tangent line is something that barely touches the circle. Okay, and then of course in geometry it's also mentioned that the radius is perpendicular to the tangent line. Now in calculus, the tangent line's definition is exactly the same. You just pick a point, and then the tangent line is something that barely just touches it. In fact, it only touches it at one point. Now the definition of the tangent line in calculus, however, is different from what you're used to before, in that the way it's defined is to draw a bunch of points from here to something close to it, and then make it and calculate the slope of this. That is, we consider, for example, this point is, say, A and f of A, okay? Considering this parabola as f, then the tangent line, this is just x, and then of course f of x. This is moving, this is fixed. So then the tangent line is defined as f of x minus f of a divided by x minus a. That is the slope of the tangent line. Okay, that's the standard definition of the slope. The difference here, however, is as we move this point, holding that point still, we imagine this point moving closer and closer to that point, which means the line you draw will more and more resemble the tangent line, assuming it even exists. If the curve itself is smooth. If it's not smooth, that's not going to work, as we will see in a second. So as this gets close, assuming the curve is smooth, then this particular number, as x approaches a, is going to exist. Okay, this limit will exist, and that is called when it does exist, we consider that the slope of the tangent at the point A and FA. As an example of that, let's say we look at a very simple example of what is this? This is x squared. So let's say we look at the very simple fx equal to x squared, and we will calculate the tangent as x equal to say x equal to minus 1. What is the tangent of this thing as x equal to minus 1? Well, you just do it exactly like this, which means we have the limit of x squared, okay, fx, minus f of a, which is just 1. A is 1, so that's just 1, divided by x minus 1, negative 1. Okay, that's the definition. And to calculate this limit, you have you pull the same trick. This is called the difference of squares or something. Anyway, so it becomes x plus 1, x minus 1, divided by x plus 1. So you have, the only thing you have, of course, is x minus 1 left. And that, as x approaches negative 1, that gives you negative 2. And that is the slope of the tangent line that goes through the point negative 1. In general, if this particular limit exists, then we say that f has a tangent line at the specific point A and F, AFA. And of course, this thing is, once this value is calculated, is called the slope of the tangent, of the line of the tangent. Now, sometimes, of course, you can think of an example that where the curve is kind of vertical. Okay, I mean, it just goes perfectly vertical right here. Such as an example would be x, such as fx equal to x to the 1/3 power. Then it looks something like this. Now, if it looks like that, then if you calculate the limit is going to be infinity, because it's going to go vertical, because the tangent line is vertical. When that happens, if the limit does go to infinity, we say that it has a vertical tangent line. Okay, now we will look at this particular example where, say, if you have a function where this is the absolute value graph. It looks like a V. the absolute value graph, what is this tangent at 0? Now, if you calculate the slope based on this side, this is just positive 1, okay? But as your f approaches here, it's always going to be 1. The value is 1, period. But if you approach from this side, the value is going to be negative 1. So then the limit therefore does not exist. And we will say that it doesn't have a tangent line at that point. That's because it has a sharp spot. Sharp spot. or sharp corner. Now next we are going to talk about what this tangent line means. And the tangent line often is considered as the velocity. That is the velocity of something, which is the distance divided by time. Okay, they consider this is the distance and this is the time, and the limit, if it exists, is used as velocity. Velocity just means speed, except that in physics it has a more complicated definition, but we're not in physics, so we don't care. So the velocity is defined as such, and and a common formula from physics gives the velocity, say, of something that's falling down, h of t equal to negative 16 t squared plus v0 t plus h. Now this is the equation of something that drops out. And this is the initial speed where you throw it, and then these are the, and based on the time, and this is the initial height. Okay, this you can call it h0. 0 means it's the initial height, and this is where the height is going as it falls. So then let's look at an example. Let's say something got dropped at say something dropped at 400 feet. Okay, you're above 400 feet and you drop something. So the question is, what is the velocity at, say, 3 seconds? That is, if you drop something at 400 feet, 3 second count, 1, 2, 3, how fast is it at that point? Well, we can calculate that. This is the equation where that comes from. So based on that, we can write down do a quick calculation of what it is. So h of t is equal to negative 16 t squared. And then initial velocity is 0 because we just dropped it. We didn't try to throw it down harder. And then plus the initial height is 400. Okay. And so then we will calculate this thing, especially based on that formula for when x. So what happens when t equal to 3? So we calculate the limit of as we need t goes to 3 of this thing. That's h of t, which we will just write it down like this. That's f. That's the first term minus the value of t equal to 3. That's minus 16 times 3 squared, which is 9, plus 400. And then divided by the bottom would be t minus 3. And you have to calculate the limit of this thing as t goes to, say, as t goes to 3. So let's crank this stuff out. It gets to be the limit of, okay. So we have this 400 minus 400, that's gone. So we have 16 times, we'll plug the 16 out, and then you have, we'll take them. Should we take the minus 16? Yeah, take the minus 16. So we have t squared minus 9 over t minus 3. Okay, this is a difference of squares, becomes t plus 3, t minus 3. So that equals to the limit as minus 16. So it's the limit time minus 16 times, I'm running out of space. I will write it over here. One more line. So it equals to the limit minus 16 times t plus 3, because the t minus 3 got canceled out. And then as t approaches 3, so it's equal to negative 16 times 6, which is equal to negative 96. And that is our velocity. And the negative means it just means it's aiming downwards. And in the next video, we'll do a couple more examples.